Hi everyone, here in this video we are going to learn iupac nomenclature of organic molecules by 7 steps with an example. Okay, why iupac nomenclature is so important? So here, from school levels to highest standards or highest academics on chemistry or competitive examinations on chemistry, we can expect at least one question from iupac nomenclature of organic molecules. So that may be from simple to highest levels based on that particular competitive examinations on chemistry. Okay, that's why one should have the basic command on iupac rules to give the correct nomenclature of given organic molecule. Okay, right, in that, first thing is, the basic is, every organic molecule has three main heads. Okay, one is prefix, followed by parent, and followed by suffix. Okay, so by combination of these three in the given respective manner, the name of organic molecule is completed by iupac rules. Okay, so whenever we are going to give iupac nomenclature of unknown organic structure, first one should look at, or one should search, principal functional group on the given organic molecule. Okay, one should have command on priorities of functional groups. Okay, so just look at the table here. You can get the decreasing order of precedence for the major functional groups. Whenever we are going to give whenever we are going to determine principal functional group, so we need to follow this order. Okay, so from top to bottom, the priority of functional groups decreases as a principal functional group. Okay, and just remember that always the principal functional group considered as suffix. Okay, for example, if we have carboxylic acid functional group and aldehyde functional group, okay, carboxylic acid functional group and aldehyde functional group on a single organic compound, then which should be considered as a principal functional group. Okay, so here, based on this priority table, COOH should be taken as principal functional group and it should be given as suffix. Okay, that means that unknown organic compound has suffix carboxylic acid. Okay, so here other functional group aldehyde should be taken as prefix because it is it is having less priority than carboxylic acid according to this table. Okay, so here the prefix aldehyde should be given as formyl. Okay, so here formyl followed by parenchyme followed by suffix carboxylic acid. That gives the iupac nomenclature of that organic compound by taking other rules here. Okay, so this first thing is, one should locate the principal functional group, or one should determine principal functional group on the given unknown organic molecule. Okay, yeah. And second step is, one should determine parenchyme or ring. Okay, so we need to look at the longest chain with the longest chain of carbons in the particular organic compound, or if the ring is more priority than a chain, then we should look for that ring size. Okay, so one should determine parenchyme or ring in the second step. Okay, we have some basics, like for example, if we have only one carbon, we can give meth as a parent name, 2 carbons eth, and 3 prop, and 4 but, like that. Okay, so just check out that. So we are not going to give the detailed naming of that parenchyme here. Okay, yeah. So second step is, simply one should look at, or one should search parenchyme or ring. Okay, right. And the third step is, name parent structure and principal group. As we said in the principal group determination, so whenever we after finding principal functional group, we need to give a name for it according to that suffix. Okay, a suffix name of that particular principal functional group, and we need to give parent structure. Okay, yeah. And the fourth step, complete the numbering for substituents. So after determining principal functional group and parenchyme, so other functional groups and substituent should be given with numbering. Okay, so and here we need to follow ascending number. Okay, so that means from principal functional group to other side. Okay, right. So first we here in the fourth step, complete the numbering for substituents and prefixes, and in the fifth step, name substituents or prefixes and determine their positions on parenchyme. Here one should use alphabetical orders. Okay, we need to follow alphabetic order and numbering, that means ascending order from parent or principal functional group to other side. Okay, yeah. In the next sixth step, assign stereochemistry. So it may have RS or EZ. Okay, so we need to look at the stereochemistry and we need to give RS and EZ nomenclature on the particular carbons. And here also we need to follow alphabetic orders and the numbering. Okay, ascending numbering order to give the locants for particular RS and EZ EZ nomenclatures. Okay, yeah. And in the seventh step, write the complete name as a single word with correct locants for substituents or prefixes. Okay, so these are the 7 steps. By using these 7 steps, one can give complete name or iupac name to the organic molecule. Okay, now just check example here. So first thing, what should we do? So according to 7 steps, first step is we need to determine principal functional group. Okay, so here on the given organic molecule, which is the principal functional group. So here we have 2. One is chlorine, one is ene. Okay, so in these 2 functional groups, which one has highest priority as a principal functional group? So to determine this, one should have the command on the chart which is given here in this video on functional group, principal functional groups. Okay, so in that case, ene has highest priority than halo group, that is chlorine here. Okay, that's why the suffix should be end with ene for this unknown organic molecule. Okay, so here we have 2 enes, that's why it should be given with diene as a suffix for this organic structure. Okay, now we need to look at that means the parenchyme. The second step is one should determine parenchyme. So parenchyme, the longest carbon chain here, so which is having 8 carbons in it, so simply acta. Okay, so that is the parent name, acta, because it is having 8 carbons in its longest chain, and which is considered as parenchyme here. Okay, and after that, so here we have just confirmed or determined principal functional group as suffix and parenchyme. The third step is we need to give numbering on the substrains here. Okay, so we need to start the just remember that here are the important points. After determining the principal functional group, we need to give a numbering from that principal functional group. Okay, that means the principal functional groups should get least numbers. Now we are going to give numbering on that longest chain or parenchyme. Okay, so we need to start numbering from this end. Whenever we start from that 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so we need to give from left side to right side, because here we need to give lowest numbering for that principal functional group. Okay, if we give the numbering from right side to left side, so it should be wrong, because whenever we give that right side to left, so just give numbering 1, 2, 3 and 4. That means the principal functional group is getting 4th, that means the highest number 4, whereas from left to right it is getting 2nd. So we need to look for the or we need to give lowest numbering to that particular principal functional group on the parent chain. Okay, so that is iupac rule. Yeah, now when giving after giving the numbering on the principal or the parent chain, so just look at the substituents. Okay, we have two substituents, right? So chlorine and methyl group, so they are on 6th carbon. Okay, chlorine and methyl group, and they are on 6th carbon. Just look at them. Here we need to look at the alphabetic, the first letter of those substrains, chlorine and methane. So in that chlorine we have C, in the methane we have M. So which is the first letter in alphabetic order? C. So that means we need to give the first priority as a prefix for that chlorine. Okay, right. So after just checking the priorities of the prefixes, now just give that means the main functional groups here, enes. We have two enes. Okay, so just look at their starting ene numbers. We have 2 here and 4. That means 2 comma 4 diene as a suffix. Okay, right. Now what is the longest chain here? So 8 carbons containing it's so here octa. Okay, octa 2 4 diene. And just move left side here, on 6th carbon we have chlorine and methyl group. So chlorine should be get a first priority as a prefix, so 6 chloro and 6 methyl. Okay, 6 chloro and 6 methyl. Okay, and after that we need to give for RS and EZ nomenclature, we should be first in the prefixes. Okay, right. Just look at just look at the enes here on the second one or second double bond. So here the first double bond, we need to look for EZ nomenclature. So whenever we are going to give the EZ nomenclature, so we need to look at each carbons of double bond. If you look at this carbon, so we have hydrogen here. Okay, and here we have CH. So which should get highest priority? Carbon gets first priority. That's why give 1 here and 2 here. The same time here we have hydrogen, here we have CH3. So carbon gets first priority and the hydrogen get second priority. Now just look at the priorities. So 1 and 1. So the first priorities are same side. That's why we need to give Z. Okay, so Z for that first ene. Okay, so 2Z. Right, now just look at that fourth, that means second double bond and 4th carbon. And here we have hydrogen here, hydrogen here. So first priority the 1, and here the first priority carbon gets 1. So these two are opposite to each other. Okay, that means here we need to give E nomenclature for it. So 4E. Okay, and here we have 2Z and 4E. Now we need to go for the 6th carbon where another stereochemical nomenclature is there. So if you look at this, is it or yes? So here one should have command on RS nomenclature. So here just give the priorities of the groups on this chiral carbon, right? So we have carbon, chlorine, and carbon and chlorine. So first priority goes for chlorine because it is having highest atomic number or mass. Okay, so first one, number one is given to that chlorine. And second priority goes for this carbon because here we consider it as 2 carbons here. Okay, and next priority goes for this because the carbon again connected with other carbon with 2 hydrogens, but here carbon is directly connected with 3 hydrogens only. So here 4th one for that. Okay, now give the that means just give that numbering from 1 to 4. So if you do that, simply it is anti-clockwise. Okay, whenever it is anti-clockwise, we should give S notation for it, S nomenclature for it. But here the methyl group is, that means the 4th priority group. Okay, our least priority group is above the plane. Okay, methyl group is just projecting towards us, whereas chlorine is backside to the plane of it. That means a 4th priority group is above the plane. That's why we need to give opposite nomenclature to that particular priority order. Okay, so here it is anti-clockwise direction, it should be yes, but the least priority group is above the plane, so we need to give R for it. Okay, so 6R. So after completing all the stereochemistry and its nomenclature, now give first thing we need to give priority for stereochemical nomenclatures. So here 2Z, okay, and 4E, comma, and 6R. Okay, after that 6 chloro, right, 6 chloro and 6 methyl acta, okay, 6 methyl acta 2,4 diene. Okay, so this is the complete name of this organic structure. Once again, 2Z, 4E, 6R, 6 chloro, 6 acta, so sorry, 6 methyl acta 2,4 diene. So by just using these 7 steps, so one can give complete or the correct iupac name for given organic structures. Okay, right. Thank you.